Hi everyone. Today I am going to discuss ordinary and exact interest. Time is an important factor in the computation of interest for a borrowed money. The interest I for a principal amount P subjected to an interest rate R for a term T days is called an ordinary interest if the time used is the approximate number of days in a year. That is, 1 year is equal to 360 days, assuming that 1 month has 30 days. So the ordinary interest is computed as the principal amount P times R times T over 360, where T is the number of days. An exact interest I sub E is obtained if the time used is the actual number of days in a common year, which is 1 year is equal to 365 days. So I sub E is computed as the principal amount times the rate times the time in days divided by 365. Remember, in the computation of interest, where a specific type of interest is not stated, that is either ordinary or exact interest, you have to use the banker's rule. That is, you calculate the interest on a loan based on ordinary interest and exact time. So we have use I sub O is equal to the principal amount times the rate times the actual number of days divided by 360. Okay, let us solve the problem. The interest rate for a borrowed amount of 6,800 is 6.3% for 72 days. Find the ordinary and exact interest. So we start our solution by identifying what are given. The principal amount is 6,800. The interest rate is 6.3%, and when used in computation should be converted to decimal. So we divide 6.3 by 100, gives us now 0.063 or 63 thousandths. The time is 72 days. We're required to find for the ordinary and exact interest. So to solve for the ordinary interest, we use the formula I sub O is equal to P times R times T over 360. Substituting values, the ordinary interest then is 85 pesos and 68 centavos. While the exact interest is computed using the formula I sub E is equal to P times R times T over 365. Substituting values, that gives us now the exact interest is 84 pesos and 51 centavos. So you will notice in the computation of these two interests, they differ only by the denominator. The ordinary interest uses the approximate number of days in a year, 360 days, and while the exact interest uses the exact or the actual number of days in a year, which is 365 days. So since the denominator in the ordinary interest is smaller, and so it gives us a higher interest, while the exact interest using a higher denominator give us a smaller interest. So from these two factors, you will notice that the ordinary interest is actually more advantage to the lender, while the exact interest is advantageous to the borrower. Okay? So here is the table for the actual and approximate time, or the actual and approximate number of days in every month and in 1 year. So for the 12 months in a year, January, February, March, April, May, June, July, August, September, October, November, December, we have 12 months. The approximate number of days is that we assume that each month has 30 days, giving us a total of 360 approximate number of days in 1 year. While for the actual number of days, we have for the common year, we have a total of 365 days. So we have 4 months having 30 days, April, June, September and November, while February has 28, so a total of 365. And then we have for leap year, February will have 29 days, giving us a total of 366 days. So maybe just a tip on how you could easily identify the months of the year having 30 days. I learned this one from my mother. So it's a sort of a rhyme. We have 30 days of September, April, June, and November. All the rest has 31 except February has 28. Okay, so there are only 4 months in the year having 30 days. So I hope you can now easily identify what are those months. So 30 days of September, April, June, and November. All the rest is 31 except February has 28. Okay, and during leap years, you have February has 29 days. So actual number of days, 365 during common year, 366 during leap year, and 360 days, approximate number of days in 1 year. Okay, so how will you know if the year is a leap year? Okay, so if the year is divisible by 4, then it is a leap year. That means there are 366 days in that year because February 29 is added in that particular year. For example, 2020 is a leap year, 2016 is a leap year, 2012 is a leap year, 2000, year 2000 is a leap year. Okay, so if the year is divisible by 4, it is a leap year. That means there is a February 29 on that particular year. In computing the time, the first day is not included, but the last day is included in the counting. If the problem does not specify what type of time, then you have to use the actual time. Okay. For example, the money is borrowed on January 1 and will be returned on January 31. How many days are you going to use in the computation of your interest? Okay, so take note. You're supposed to start counting. Since 1 is not included, you have to start counting 2, 3, 4 up to 31. Or simply, you just subtract 31 minus 1. That means the computation for the interest will be that for 30 days. Let us practice solving for the actual and approximate number of days between February 13, 2020 to October 26, 2020. So you make the table showing the months from February to October. So to determine the approximate number of days, we just assume that all the months has 30 days. So we have 30 days for the month of March, April, May, June, July, August, September, October. Since we end on October 26, so we have now, there are only 26 days in October. Since the money was borrowed on February 13, so for the month of February, for the approximate number of days, assuming you have 30 days in February, this will be 30 minus 13, or you have 17 days for the month of February, giving us a total approximate number of days equal to 253. For the actual number of days, so we started with February 13. So for the month of February, since this is 2020, this is a leap year, we have 29 days in February minus 13. There are 16 days for the month of February. And then we have 30 days of September, April, and June has 30 days. The rest has 31. So October, we end up October 26. So again, for the month of October, we only have 26 days, giving us a total of 256 actual number of days. Another method of determining the approximate time or the approximate number of days between dates is to convert the dates into numerical symbols following the format year, month, and day. So starting with, you have October 26, the latest date, October 26, 2020. We write this one as 2020, 10 for October, and then the day is 26. February 13, 2020 is written as 2020. February is 2, and then the day is 13. And then what you're going to do is to subtract the year, month, and the day. We start with the day. 26 minus 13 is 13 days. 10 minus 2 is 8, 8 months. 2020 minus 2020 is 0. So we have now the approximate number of days since there are 30 days in a month. 30 times 8 or 8 times 30 plus the 13 days, giving us now the approximate number of days is 253 days. Okay, so let us now determine the actual and approximate time from November 13, 2020 to March 28, 2020. So we construct the table showing the actual number of days, month, and approximate number of days. So from November 13, 2018 to November 13, 2019, this is 1 year. And since this is a common year, we have 365 actual number of days and 360 approximate number of days. Then for the remaining days for November 2019, so starting from November 13 to 30, 2019, there are 17 days, actual number of days, and also 17 approximate number of days. For December 2019, this is 31. It has 31 actual number of days and 30 approximate number of days. January 20, 2020 has 31 days and 30 approximate number of days. February 20, 2020 is a leap year, so there are 29 actual number of days and 30 approximate number of days. So we have here, we end up March 28, 2020, so 28 days for the month of March, and here 28 days. So we get the total, we have 501 actual number of days and 495 approximate number of days. Okay, so let us determine the approximate time or number of days from November 13, 2018 to March 28, 2020 using the second method, that is, we write the dates following the format year, month, and day. So starting from the later date, March 20, 2020, this is written as 2020, month is 3 for March, and then the day is 28. November 13, 2018 will be written as 2018, November is 11, and the day is 13. Then we are now going to subtract the day, month, and then the year. But you will notice in here that we cannot subtract, of course, 11 from 3. So what we're going to do is we borrow 1 year from 2020. And 1 year is equivalent to 12 months. And so that will give us now, March 20, 2020 will now be written as 2019. The 1 year in here, which is 12 months, is added to 3. That gives us now 15 months. The day is 28. And November 13 is 2018, 11, 13. So we are now ready to subtract. Okay, we have 28 minus 13 is 15. 15 minus 11 is 4. 2019 minus 2018 is 1. That means we have 1 year, 4 months, and 15 days. So the approximate number of days, 1 year is 360 days. 1 month is 30 days, and we have 15. So we have 360 plus 4 times 30 plus 15, giving us a total of 495 approximate number of days. Let us solve the problem. Find the ordinary interest on 45,800 at 6.25% from March 26, 2019 to October 11, 2019 using the actual and approximate time. We start our solution with identifying the given. We have the principal amount is 45,800. The interest rate is 6.25%, which is when converted to decimal is 0.0625, and then the time is given in terms of date, that's from March 26, 2019 to October 11, 2019. And we are required to find for the ordinary interest using the actual time and the ordinary interest using the approximate time. So we start with solving for the time. So to determine the actual and approximate time from March 26, 2019 to October 11, 2019, we construct the table showing the actual number of days, the month, and the approximate number of days. So starting from March 26, 2019, the actual number of days will be 31 minus 26, and that's equal to 5 days. For the month of April 2019, we have 30 days. May 2019 has 31 days, June has 30 days, July has 31 days, August has 31 days, September has 30 days, October, then we end at October 11, so 11 days for the month of October. So the actual number of days is equal to 199. For the approximate number of days, starting from March 26, we assume that we have 30 days in March. So we have 30 minus 26, that is 4 days for the month of March. April has 30 days, May, June, July, August 30 has 30 days, and October 11, we end at October 11, so 11 days for the month of October. That give us a total of 195 approximate number of days. Using the second method of finding for the approximate time between two dates, October 11, 2019 will be written as 2019, 10, 11. March 26, 2019 will be written as 2019, 3, 26. So if we are going to subtract now the days, we have 11 minus 26, so we cannot do that. What you're going to do is borrow 1 month from 10, so it becomes now 2019, 9, and 1 month is equal to 30 days, so 11 now becomes 41. Then we have 2019, 3, 26. So subtracting now the days, we have 41 minus 26, that gives us 15 days. And 9 minus 3 is 6 months. That means we have, so 30 days for 30 days in a month. That will give us now 6 times 30 plus 15, or a total of 195 days. So we are now ready to solve for the ordinary interest using the actual time. The formula is the principal amount times the rate times the actual time divided by 360 days. Taking note that for ordinary interest, our denominator will be 360. So the principal amount is 45,800. The rate of interest in decimal is 0.0625. The actual time is 199 divided by 360, we have now the ordinary interest using the actual time is 1,582 and 33 centavos. Solving for the ordinary interest using the approximate time, so we have the formula, ordinary interest using approximate time is equal to the principal amount times the rate of interest times the approximate time divided by 360. Substituting now the formula, we have 45,800 times 0.0625. The actual number of days is, or the approximate number of days is 195 divided by 360, and so the answer is 1,550 and 52 centavos. So if we look at now the computed interest, you will notice that the ordinary interest using the actual time will give us a higher interest. This is because the actual number of days will always be greater than the approximate number of days. Let us solve the problem. How much interest should be paid on August 6, 2020 for a borrowed amount of 42,300 pesos on October 11, 2019 at an interest rate of 8.2%? So we start our solution by identifying the given. The principal amount is 42,300 pesos. The interest rate is 8.2%, or when converted to decimal, 0.082. The time is from October 11, 2019 to August 6, 2020. And we are required to find for the interest. So you will notice that in this problem, there is no mention on what type of interest and time will be used. Therefore, we have to use in here the banker's rule. That is, we are to find ordinary interest using the actual time. So the formula now will be I is equal to the principal amount times the rate times the actual time divided by 360. Solving for the actual time from October 11, 2019 to August 6, 2019, we make the table showing the month and the actual number of days. So starting from August 11, 2019, then you have November 2019, December 2019, January 2020, up to August 6, 2020. So, starting from October 11, the actual number of days will be 31 minus 11 or 20 days. November has 30 days, December has 31 days, January has 31 days, February 2020 has 29 days, March has 31 days, April has 30 days, May has 31 days, June has 30 days, July has 31 days, and August, we end up at August 6, so we have 6 days in August. That gives us a total number, actual number of days equal to 300. Solving now for the ordinary interest using the actual time, that will give us now the interest or the ordinary interest using the actual time is equal to the principal amount times the rate times the actual number of days divided by 360. Substituting now the values, the interest therefore is 2,880.86. So that ends our discussion on finding the exact and the ordinary interest and using the actual time and the approximate time. Thank you.